Hello guys, welcome to my channel. In this lesson, we are going to learn how to simplify radical expressions by removing factors from the radicands. All right, let's go ahead and look at one example. The first example here is going to be to find or to simplify the fourth root of 48. All right, so I'm going to look at the factors of 48 quickly. So I know that 48 can be factored into 2 times 2 times 2 times 2 times 3. So I'm just looking at the factors of 48. Okay, so I know that 2 times 2 is 4, 4 times 2 is 8, times 2 is 16, and times 3, that will be 48. So the reason why I'm doing this is because I'm looking for fourth roots. So I'm looking for repeated factors. Okay, I need 4 repeating factors, okay, of in 48, okay, because I know 48 actually is like 4 times 12, yes, and 4 times 12 in itself is 2 times 2, yes, and for 12 I have 4 times 3, and 4 means for 2 times 2. So you can see all these repeating factors, yes. So actually what I'm doing here is looking at the prime factors of 48, the product of prime factors of 48. So in that way I'll be able to find the fourth root, okay, of this part, yes, which is just like 16 times 3 actually. So what I'm having here, it looks like I'm having to look for the fourth root of 16 times 3, because that's what 48 looks like. Now you try to take the fourth root of 16. Again, you can see the copy will be 2, so that will be 2, and then you have the fourth root of 3 left, so you just write that in like that and put fourth root. So that's it. That means you have 2 times the fourth root of 3. That's how you simplify that. So let's take another example. Let's look at this algebraic radicand 16 x to the 7. Okay, and we're looking at to find the square root by removing factors from the radicand, which is 16 times x to the 7th. Again, I know that 16 is 4 times 4. All right, because I'm looking for square roots. Okay, so 16 is 4 times 4. But then let me look at the factors of x to the 7th. I know that x to the 7th means x times x times x times x times x, and so on. All right, times x. I'll count 1, 2, 3, 4, 5, 6, 7. So what I'm going to do here is to group each one because I'm looking for square roots. So I'm just going to be grouping two repeating factors together. Yes, and I'm left with one of them. So I'm just going to leave that one alone. That means I got to take one of this x as the square root, take one as the square root, and take one x as the square root. I'm just left with this one here. So what I'm going to do here is to now rewrite the expression to look like 16, which is the perfect square number, times x to the, which is to the sixth power. You know, x times x times x times x times x is x to the sixth power, times the single x that I have here. So now to simplify this, I'll just take the square root of 16, which is 4, and the square root of x to the 6th will be x times x times x, which is x to the third power. So that escapes from the square root. So these are the numbers coming out from the radical sign. So then I have a single piece of x which cannot get out of the radical sign. So it'll be the square root of x. So this is how you finish that off. Let's take more examples. Let's look at this example right here that's asking us to find the third root of x to the 6th and y to the 6th. All right, so what I can do here is to look at, I know x to the 6th means x to the squared times x to the squared times x to the squared. So this is one way I'm looking at that. So 2 plus 2 plus 2 gives 6. That means I can do that. So that means the third root or cube root of x to the 6th will be x to the squared times. So, and then I'm going to do for y now. So it will be the same thing. So y to the squared. So your final answer will be x squared and y squared, which you can put together like that. So they have the same exponents, and then you can wrap them up and keep them in this in one with one parenthesis. All right, so this is how we can solve this problem. So let's go ahead and do more. The more we do, the better we become. All right, let's do find the third root of negative 128, 128, then x to the sixth, and y to the fourth. All right, so there are a lot of numbers here. So, okay, so what we can do here is to break 128 into some factors that we can manage, okay? Oh, of course, it's negative 128. So from here, I know 128 is looking like something that I can factor into negative 64 times 2. Yes, negative 64 times 2. And I know that I can find the cube root of negative 64. So which means negative 4 times negative 4 times negative 4. And that will give negative 64. And then I just have times 2 left. So that means the cube root of this result would just be negative 4, right? So, okay. And I'm going to move to the x variable. For the x to the sixth, all I'm going to do just see if this 3 divides the exponent. That's a shortcut. So just take 6 and divide it by 3. If you can do that, that means the cube root of x to the sixth will be x to the second power. Okay? So for x to the sixth, if I took the cube root of that, it will just be 6 divided by 3, and it will be x to the what? Second power. So that's a much more efficient way to do that. All right, so for y to the fourth, I know that y to the fourth means y times y times y times y. So I can just group these three together because I'm looking at the cube root of that. So the cube root of y to the third power, which is y to the third power right here, okay, it will be y. But then this final y does not have, mm, cube root or pairs. So that will just keep that one in the cube root. So now I'm going to put all the pieces together. So for negative 128, I am having a negative 4, right? With this number here, which doesn't get out of the radical sign. So I put 3 over there. I'm done with this part. I'm going to go to x to the sixth, which we got as x squared. Multiply that with x squared. I'm going to go to the final part, which is for y to the fourth, which I got as y multiplied to the third root of y. So it will be y multiplied to the third root of y. So now all the numbers that got out of the square root would need to be together. So this number, we use red, this number is out of the radical sign, and these two guys are also out. So it'll be negative 4x squared y, but then 2 and y are still there. So I'm just going to keep them together in the radical sign. So since they're both still in the radical sign. So this is how you would simplify a problem like this one. I hope you're able to learn something. Come back to this channel for more videos. Thank you very much.